Well, today in Math 30-1, we're going to cover topic 1.3. What we're going to do today is combine the transformations that we've learned in sections 1.1 and 1.2. Here we go. So we're going to start with some function, y equals f at x. And what we're going to learn is that the first thing we're going to do is our horizontal and vertical translations. Now they can be done in either order, but just to be consistent, what we're going to do is follow the book, and we're going to do the horizontal stretch first. That's going to be about the y-axis by a factor of 1 over b. Now, if there is also going to be if b is negative, there's also going to be a reflection in the y-axis. After that, we're going to do our vertical stretch. Now the vertical stretch is straightforward. That's going to be about the x-axis by a factor of a. Absolute value of a, meaning if a is negative, there's also going to be followed by that is going to be a reflection in the x-axis. After that, we're going to do our horizontal and vertical translations, or shifts. The horizontal translation is going to be h units, and the vertical translation is going to be k units. And that's from this equation, y equals a times f of b times x minus h plus k. And again, a is going to be our vertical stretch. 1 over b is going to be our horizontal stretch. H is going to be our horizontal translation, and k is going to be our vertical translation. The other way you could see this written as y minus k, but in this chapter, or in this book, we're not going to be using that. So in example 1, we're going to look at the transformation y equals 3 times f of 2x. So if we give you a graph with these ordered pairs, 1, 1, 4, 2, 9, 3, we're going to transform it into y equals 3 times f of 2x. And that's going to take 2 steps. Our first step can be dealing with the horizontal stretch of 1 over 2. Because if b is 2, the horizontal stretch is going to be 1 over 2. So that means every x value is going to be half of what it was before. So 1, 1 is going to be 0.5 and 1. 4, 2 is going to be the 0.22. And 9, 3 is going to be the 4.5 and 3. Next, I'm going to deal with a vertical stretch of 3. So the point 0.5 and 1 is going to be the point 0.5 and 3. The next point, 2, 2, is going to become 2, 6. My y values are going to be multiplied by 3. Lastly, 4.5 and 3 is going to be 4.5 and 9. Now that's going to give me the blue graph is the final graph that I'm looking for. And those are the ordered pairs. That's my vertical stretch of 3. Let's look at another one. Y equals f of 3x plus 6. Now I need to factor the 3 out of both of those terms. Now I'm going to be in the form of above, or f of 3 times x plus 2. So my b value is going to be 3. My horizontal shift is going to be 2 units. So now what I can say is that I'm going to have a horizontal stretch of 1 over 3, and I'm going to have a horizontal shift of 2 units to the left. So I'm going to start my graph over and draw it in black. Same one I started with before, with points at 1, 1, 0, 0, 1, 1, 4, 2, and 9, 3. Now what I'm going to do is I'm going to first of all do my horizontal stretch of 1/3 So my first point, instead of being at 1, 1, is going to be at 1/3 and 1. That's that point there in red. The next point is going to be, instead of at 4 and 2, is going to be at 4/3 and 2. And the last point, instead of being at 9, 3, well, 9 divided by 3 will give me 3, so it's 3, 3. So in red, if I join the dots, there's my transformation of my stretch, horizontal stretch of 3. Now I'm going to have to shift everything 2 units to the left. So every point I'm going to draw in blue 2 units to the left of where it presently is, and draw a circle, draw my line in there. So 0, 0 went to -2, 0, 1/3 and 1 went to -5/3 and 1, 4/3 and 2 went to -2/3 and 2, and 3, 3 went to 1/3 and 3. And that's the graph, my final graph in blue. Moving on to example 2, starting with, we're given the graph of f at x equals x squared. We're going to list the combination of transformations that are going to be applied in the correct order, so that we're going to take the graph of y equals x squared and obtain the graph of g of x, which is -1/2 times f of 2 times x minus 4 plus 1. Well, let's do our horizontal stretch first. That would be a horizontal stretch of 1/2. Followed by, secondly, a vertical stretch of 1/2. Then that's going to be followed by number 3, and that's going to be a reflection in the y-axis. I'm sorry, the x-axis. We're on to our a value. Lastly, there's going to be a double shift, because we're going to have a translation of 4 units to the right and 1 unit up that we can do at the same time. There's pictures of this shift in a series of pictures on page 36 of your textbook. Moving on to example 3. We're going to give you a graph of the absolute value of x. There you have it. Now what we're going to do is I'm going to give you in red our final transformation. Now what I'm going to ask you to do is describe it. There's f of x, there's g of x. Describe the equation that's going to take you from f of x to g of x. So what is g of x compared to f of x? Well, first of all, let's look at our stretch, our horizontal stretch. Notice that the top of our graph is 8 units apart, whereas my transformation is only 2 units apart. That means I must have had a horizontal stretch of 1/4, because it's only a quarter as big now, but that means that my b value is going to be 4. Now, what's the vertical stretch? Well, originally, you'll notice, well, it's telling you it's 2, because that's 4 units, and my transformation is 8 units. That's 2 to get there. I'd have to multiply it by 2. Now, there's going to be a vertical shift, translation, of 2 units up to get me from the black graph to the red graph, and there's going to be a horizontal translation of 7 units to the left. So to put that all together is y equals a times f of b of x minus h plus k. We can say that y is equal to, well, a is 2, f of b is 4, times x minus h, well, that means it's going to be x plus 7 for 7 units to the left, plus 2. And that's it. Your assignment, is going to be to do page 38, numbers 1 to 6.